Hey everyone, welcome to this data analysis tutorial. In this session, I'm going to explore a dataset that contains various product information, including categories, prices, discounts, ratings, and reviews. Throughout this tutorial, I will guide you through several visualizations and analyze to uncover insights from the data. I will start by examining the distribution of products categories, then dive into price and discounts structures. I will also explore how products are rated and which categories receive the most reviews. So, by the end of this tutorial, you will have a solid understanding of how to analyze product data and create insightful visualizations with Python. So, whether you are new to data analysis or just looking to brush up your skills, I'm glad you are here. So, let's get started. First, I'm gonna import some necessary libraries, which is NumPy, Pandas, Matplotlib, Seaborn. Okay, so now execute it. Okay, so now import the files. Import basically our data, which is Amazon data. So let's execute it. Now let's see the data. So this is our data that we will work on today. Now let's just check how many columns are or which columns we have in this data set, right? So let's check it out. Now let's check the shape of the data set. Now check the data types of each column. Now the clean and convert price function takes a column of prices and does a few things to clean it up. First, it ensures a string. This makes sure the data can be manipulated like text. Then it removes the currency symbol. Then it removes commas and convert to float. Right. So after defining the function, it applies to columns in the dataset. Then discounted price and actual price. Basically, this way, these columns contain clean, consistent numbers that we can use for calculations or data analysis. Right. When we see percentage like 64% or 43%, it's easier for us that understand them as whole numbers with a percent sign, right? But when we are working with the data in a programming context, it helps to convert this into decimal form for calculations. So this does things to make the transformation to happen, remove the percent sign or convert to a decimal fraction, right? So this decimal format is handy when we want to do calculations with these values, like figuring out how much a product's price was reduced or finding the average discount. By the end of this process, we have taken a column with a mix of text and numbers and transformed it into clean decimal numbers that are ready for deeper analysis. Right. Now let's take a look at the distribution of rating in our dataset by using the value counts functions to see how frequency each rating occurs and giving us an idea of the overall customer's sentiment, right? Now let's use the query method to find all rows in our dataset where the rating is just a pipe character, right? And it indicating potentially incomplete or corrupted data. So now let's replace any instances of the pipe character in the rating column with a default value of 4.0, and then convert the entire column to a floating point format for further numerical analysis. Right? So let's do it. Now let's clean the rating count column by removing any commas and converting the text into a floating point format. And ensure we have to clean numerical data to work with for analysis. Now let's identify any duplicated row in the dataset using the duplicate method, and then retrieve these duplicates for further inspection to understand the potential reasons for their repetition. Right. Now let's check for missing values in our dataset by using the isNull.sum method, which will tell us how many null or none values are in each column. So it helps us identify areas that need data cleaning or imputation, right? So the result shows that only the rating count columns contains missing values with a total of 2 null entries, while all other columns in the dataset are complete, right? Now let's create a new data frame which is called df1 by selecting and copying key columns from the original data frame, and then focusing on product related information like ID, name, category, prices, discounts, and ratings details like this. Okay. Now let's split the category column into separate components. Wherever there's a pipe character, that creating a new data frame cat split where each split segment gets its own column for more granular analysis. Right. Now let's rename the columns in the cat split data frame to give them more meaningful names, with the first segment becoming category 1, the second becoming category 2, and the third becoming category 3, like this. Okay. Now let's add the first two split categories from cat split to our data frame 1, and then drop the original category column since we have already split it into its components, then allowing us to focus on the new or more detailed category information. Right. Now let's see the frequency of each unique value in the category 1 column to understand the distribution of the primary product category in our dataset, right? Okay. So the result shows that the most common primary category is electronics with 526 entries, that followed by computers and accessories with 453, and home and kitchen with 448, while the other categories have significantly fewer entries. Now let's clean up the category 1 column by adding spaces around ampersands or updating compound terms with proper spacing. This is basically for the better readability. Okay. Now let's see the frequency distribution of values in the category 2 column to understand the column secondary categories in our dataset. So the result shows that the most common secondary category is accessories and peripherals with 381 entries, followed by kitchen and home appliance with 308, and home theaters, TV, and video with 162, and indicating a broad range of product subcategories in the dataset. Right. Now let's clean up the category 2 column to improve readability by adding spaces around the ampersands, inserting spaces after the commas, and updating compounds word with the proper formatting. We know Basically, these making the data more understandable and ready for further analysis. Okay, now let's use the string strip method on the product ID column to remove any leading or trailing white space, then ensuring that all products IDs are clean and consistent for further analysis or operations. Right. Now let's create a new list called rating score to categorize product rating into descriptive level. We loop through the rating column and assign a label based on the value of the score. So if the score is less than 2.0, it's labeled as poor. If the score is between 2.0 and 2.99, it's below average. And between 3.0 and 3.99 is average. From 4.0 to 4.99, we call it above average. And if the score is exactly 5.0, then we label it excellent. So this categorization helps convert numerical ratings into more initiative descriptors, and this makes the data easier to understand and communicate. Right. Now let's take the rating score list from the earlier and add it as a new column in our data frame df1, then convert it. Okay. So this allows us to set a specific order for the categorization. So below average, average, or above average, or excellent. Basically, this ordered categorization is useful for analysis and storing, right? Next, we create a new column that is basically difference price, which calculates the difference between actual price and discounted price. So this gives us a clear view of how much a product is discounted in terms of actual currency. So this information is valuable for understanding the price reduction on different products, right? Now let's create a new data frame, that is reviewers. So this contains the unique identifiers and names of the users who have provided reviews. This gives us a reference point for analyzing reviewer related information, right? Now let's split the user ID column in the reviewers data frame at each comma and store the results in a new variable, that is reviewer ID split. So this will contain a list of individual components for each user ID, and this allows us to work with the separated elements, right? Now let's use the explode function on the reviewer ID split to expand the list of the user IDs into individual rows. Okay, then we will create a reviewer ID exception. Then we reset the index with drop equal true to avoid carrying over the original IDs. Okay, so resulting in reviewer ID clean, which has a clean sequence of unique user IDs on separate rows. Right. So this transformation is useful for analyzing individual user IDs even if they are originally grouped together. Right. Now let's split the username column in the reviewers data frame at each comma, storing the result in reviewers name split, which contains a list of individual names for each user. So this helps break down compound usernames into their distinct compounds for easier to processing and analysis. Okay, now let's create two new data frames, which is df21 from reviewers ID clean and df22 from reviewers name clean, and then merge them into df2 and aligning them by the index to combine user IDs with their corresponding names, right? And next, let's set up the style and color palettes for our Seaborn plots using a dark grid background and ice fire color scheme, right? Then let's extract a subset of columns from DF1 to create a new data frame, that is a main sub with category 1, category 2 and a product ID. Then we will rename these columns to main category and subcategory and product ID for clarity. Okay. So using this subset, let's create a pivot table, which is main sub pivot, where we index by main category and subcategory, and then count the number of product ID entries in each combination. So this gives us a clear view of the distribution of products across different categories and subcategories, also providing valuable insights into the product compositions in our dataset, right? Now, let's identify the top 5 most common main categories in our dataset. So, here we will do this by counting the occurrence in category 1 and storing the result in most main items, which is reset to have a clear index and name counts, right? And then next, let's create a bar plot to visualize these top 5 main categories using Matplotlib and Seaborn. So we set up a plot with a size of 8 multiply 5 inches, and we use Seaborn SNS.bar plot to create a horizontal bar chart, and that showing the counts of products for each of these categories. So we then label the axis and set a title for the context. So finally, to make the bars more informative, we add label to each bar with x bar dot label, right? So these basically shows the exact count values, and the plot provides a clear visual representation of the distribution of products across the most common main categories, which can be useful for understanding trends and focusing on product or popular product areas, right? Now let's determine the top 10 most common subcategories in our dataset by counting the occurrence in category 2. We store these results in most sub item and then rename the index to category 2, and then add a column for counts, right? So next, let's create a bar plot to visualize the distribution of these subcategories. So we set up a 8 multiply 7 inches figure with Matplotlib and use the Seaborn to create a horizontal bar plot. So the x-axis represents the count of products while the y-axis displays the subcategories, right? So we then set the axis label and a plot title, and then add a bold font style to emphasize key elements. To make the chart more informative, we add bar level showing the exact counts, and the resulting plot helps us quickly identify the most common subcategories. So, and basically offering insights into the product distribution and guiding further analysis or business decisions, right? Now, let's find the top 5 most expensive products after discount. So, we start by sorting the data frame, which is DF1, by discounted price in descending order to get the products with the highest discounted price, right? So, we then use Seaborn to create a horizontal bar plot to display these top 5 products with the x-axis showing the discounted price in Indian rupees, and the y-axis listing the product names. To enhance clarity, we set a bold title and bold label for both the x-axis and y-axis. So this bar plot gives a clear visualization of the most expensive products after a discount, then helping us identify high valued items in the dataset, right? Now let's identify the top 5 cheapest product after discount. So to do this, we sort the data frame, which is DF1 by discounted price in ascending order, so that the products with the lowest discounted price are at the top. So we use Seaborn to create a horizontal bar plot showing these top 5 cheapest products with the x-axis representing the discounted price in Indian rupees and the y-axis listing the product names. So to improve readability, we add a bold title and then use bold font for the x-axis and y label. So yeah, this plots gives a clear visual representation of the most affordable products after discount and provides the insights into the budget-friendly option in our dataset. Right. Now let's find the top 5 products with the largest difference between their actual price and their discounted price. So this will give us an idea of which products offer the biggest price cuts due to the discounts. So to highlight key information, we set a bold title and as usual bold font for the excess labels. So yeah, this provides insights into the significant prices and reductions in the dataset. Okay, so let's execute it. Now let's focus on the numerical columns in data frame 1 to calculate the correlation matrix, which helps us understand the relationship between these numeric features. So first we create numeric data frame which contains only the numeric data from data frame 1 by using the select data types method with the include equal number argument basically. So next we calculate the correlation matrix, that is core matrix, to identify how the columns in the subset relate to one another, right? So using matplotlib and seaborn, we create a single subplot to display a heat map of the correlation matrix. So we set a specific color palette, that is pastel one, and include annotations to show the actual correlations values within each cell. So the heat map is square for a uniform look, and we add a bold title for context. So finally, we display the heat map with PLT show by providing a visual representation of correlations among the numeric columns, which can guide further analysis and feature engineering. Right. Now let's visualize the distribution of products rating and the number of ratings each product has received. So we create a subplot with two panels side by side. So setting the overall figure size with 15 multiply 5 inches for a broader view. The title for the entire plot is set to rating an amount of rating distribution with a bold larger font, and to maintain some spaces between the subplots we use tight layout with a padding of 3.0, that basically preventing overlapping elements, right? So in the first subplot we use a histogram to display the distribution of ratings in data frame 1, right? Then setting the number of beans to 15 and including a kernel density estimated KDE for a smooth line over the histogram, the color is set to blue, right? So in the second subplot, we plot a histogram for the distribution of rating count. So these basically use 10 bins with a purple color and KDE for smoothing, right? So we then label the X and Y axis with bold text to highlight them and add individual titles to each subplot. So basically, rating subplot and amount of rating distribution, the result is a clear visualization that basically helps understand the spread and frequency of product ratings. So offering insights into customer feedback patterns, right? So the result shows that the distribution of rating as depicted in the left graph indicates a pattern where most rating clustered around certain values, and the x-axis represents the rating values and the y-axis denotes the count of the rating for each values. So basically this appears to be a higher frequency of rating around the lower end of the scale, right? So in a right graph, it illustrating the distribution of the amount of ratings basically, right? So we see the majority of the products tends to have a rating count with a specific range, right? Now let's examine how ratings are distributed across different products and main categories using a box plot, so which is great for visualization that spread and skewed of data, and as well as identifying outliers. First we create a subplot with 10 multiply 6 inches figure, then providing ample spaces for our plot. So we then use Seaborn to generate a box plot with rating on the x-axis and category 1. So the main product category on the y-axis, this basically setup helps us understand the distribution of rating for each product category, right? So we set the x-axis label to rating and the y-axis label to product main category. So both with the bold font for clarity. So the plot title basically we set rating distribution by product main category, and this also bold and set to a large size. So with a significant upward adjustment, basically y is equal 1.0.3, so to prevent overlap with the plot, right? So finally we display the plot and showing how ratings vary by product main category, right? So this visualization helps identify which product categories tend to have a higher or lower rating, and where there might be significant variability or outliers, that provides the valuable insights for products management or marketing strategies, right? Now let's explore the rating distribution by product subcategory to understand how different subcategories of products are rated by customers. Basically, we start the creating a subplot, then the x-axis is labeled as rating, and after setting up the plot, we showed it. Right. So presenting the distribution of rating for each subcategory, this basically plot helps identify which subcategories tends to receive higher or lower rating, and highlights where there is a significant variability or outliers. So it's useful for business and product management to understand customer feedback patterns at a more granular level, right? So that's why we did it. Now let's create a bar plot to visualize the percentage of products within each rating category. Basically, this will help us understand the distribution of ratings across all products in our dataset, right? So we start by setting up a Seaborn bar plot with rating, and on the x-axis count, on the y-axis to ensure the rating are displayed in a specific order. So we use the order parameter with rating ordered, which listed the desired sequence for the bar. So we applied a specific color palette to add the visual appeal. To improve clarity, we set the x-axis label to rating category and y-axis label to percentage. So both with bold font for emphasis. So the plot title is set basically the rating of all products in percentage, and this is styled with bold font, larger size, and adjust slightly upward, like we set y is equal 1.0.3 to avoid overlap, right? So we use the bar label method to add numeric label to each bar. So this makes it easy to read the exact percentage for each rating category, right? So that's what. Finally, we display the plot, and the visualization gives a clear overview of how different products are rated and providing insights into which rating categories are most common and allowing for a quick comparison between them, right? So the result shows that the majority of products, about 75.6%, are rated as excellent, and this indicates high customer satisfaction. and a smaller proportion, 23.8%, falls into the average category. Basically, then suggest the moderate satisfaction, while only a 0.004% products are rated below average, and these points to very low dissatisfaction. So this distribution highlights the most customers have positive experience with the products. So with only a few outliers receive the lower ratings, right? Now let's identify the top reviewers who have given rating and reviews for more than one product. So here we use a bar plot to visualize the 10 most active reviewers based on the number of reviews that they have provided. So first we create a data frame called top reviewer that counts how many times each reviewer's name appears in our dataset. So we take the top 10 reviewers and then sort it by their review counts and rename the axis for clarity. Next, we generate a Seaborn bar plot with these top reviewers on the y-axis and the counts on the x-axis. So we use the bar level method to add numeric labels to each bar, and this making it easy to this makes it easy to see how many reviews each reviewer has contributed. So we set the x-axis label to amount of rating review given and the y-axis label to reviewer's name. So both with the bold font for emphasis, and then the plot title is top 10 active reviewers. And finally, we display the plot with the bar plot gives us a quick insight into the most active reviewers. So this allows us to understand who are the key contributors to product rating and reviews in our dataset. Now let's examine the distribution of actual prices and discounted prices for our products. So we will use a dual histogram plot to visualize this distribution, which help us understand the range and commonality in prices in our dataset. So first we create two histograms in a single figure, and one for actual prices and another for discounted prices. So here we set a large figure size for clarity with the histogram side by side. And we then set a main title, actual prices and discounted prices distribution, and here we use a heavy font weight to emphasize its significance. So for the first histogram, we plot the distribution of actual price using 8 bins for granularity and adding a kernel density estimated for a smoother representation. We use red for the color to distinguish it for the second plot, and the x-axis represent the actual price in rupees and the y-axis represent the count or frequency of each price range. For the second histogram, we plot the distribution of discounted prices in a similar way with the same number of bins and KDE. We use orange for its color to distinguish it from the first plot. The x-axis represents the discounted price and the y-axis shows the count. So we set titles, label and color to ensure clarity, and then the subplot layout has padding for better readability, and we finalize it to display the plot. Overall, basically, this visualization provides insight into the distribution and range of actual and discounted prices, and this helps us identify pricing trends and how discounts impact the pricing structure, right? Now let's visualize the distribution of discounted percentage using a histogram with a light gray border for a clear or professional look. So this histogram will give us an idea of the frequency and range of discounting in our dataset. So here we use Seaborn, and to add a smooth curve over the bars we enable the KDE, and then we choose royal blue for the bar color to make it visually appealing, and light gray for the edges color to clearly define the borders of the bars. So here x-axis represents the discounted percentage, while the y-axis shows the count or frequency of each discount ranges. So here we set the number of bins to 8, that basically provides a balance between detail and readability. And for labeling, we set a bold font weight for the x and y axis labels. So this indicates the discount percentage and count respectively. And here the title is discount percentage distribution. So this has a heavy font weight with a larger size font emphasis. So after setting all the configuration, we use plot.show method to display the plot. So this histogram helps us to understand the distribution of discount across the products. And this basically highlights how often specific discounts percentage occur, and which discounts are most common, right? Alright, now let's create a scatter plot to visualize the range of actual prices across different product main categories. This plot provides insights into the pricing distribution within each category, and this helps us to identify the patterns or outliers. So here we use Seaborn, and for the x-axis, and category 1 basically representing the product's main category, and on the y-axis by setting the alpha parameter to 0.3, and we ensure a degree of transparency basically that allows to overlap data points to be visible. And the color is basically steel blue that provides a calming yet distinct visual appearance, right? So we adjust the plot size to ensure the data is displayed basically comfortably, that basically using a figure size is 13 to 7. The x-axis is labeled actual price, and the y-axis is labeled product main category. So basically the plot title is actual price ranges by product main category. Now let's finally, after setting the configuration, we use plot.show method to display the scatter plot. Okay, so this visualization basically helps us to see how the actual prices vary among different main categories, right? So also this provides a comprehensive view of the product pricing in a landscape, right? Okay, so now let's create a scatter plot for the examine the range of discounted price, and basically across different product main categories. So this scatter plot can help us to understand how various product categories are priced after discount are applied, right? So here we set the plot size to 13 to 7, and this ensure basically the x-axis is labeled discounted price and the y-axis labeled as product main category. Right, so after setting these configurations, we use the plot method to display the scatter plot. So let's just execute it. So this visualization basically allows us to observe the variation in discounted prices among different main categories, and this provides the valuable insights into the impact of discounts on various product groups, right? Okay, so again let's create a scatter plot to examine the range of actual prices for different product and subcategories basically. So this will help us visualize the price distribution across more specific categories within our dataset. And basically, to ensure there enough space for the data, the plot size is set to be 13.7, and x-axis is labeled actual price and the y-axis labeled as product subcategory. And the title is set actual price ranges by the product subcategory. So let's just execute it. Okay. So here we can see the plot basically reveals how actual prices vary among different subcategories, right? So this also provides insights into the price structure within each group. Okay, so now let's plot again a scatter plot to visualize the distribution of discounted prices across different product subcategories. So this also helps us to understand how discounting impacts various product groups. So here basically x axis as discounted price and y axis as product subcategory, and the title is said to be discounted price range by product subcategory. So these visuals, basically the scatter plot helps us to reveal how discounted prices vary among different subcategories and also provides a visual guide to the discounted price structure within each group. Alright, so that wraps up our data analysis tutorial. I hope you found it useful and learned a few new techniques for exploring and visualizing the data. So if you have any question or want to explore other topic, feel free to reach out. I would love to hear from you. Thanks for joining me today.